All right, now in section 4, we're still going to be solving systems by elimination, but we're going to put a little bit of a twist into these sets of problems. But let's go back and review just like we always do. There are three things that are going to happen, or one of three things that will happen when you solve a system of equations. What are those three things that are going to happen? Well, again, number one, the two lines could intersect. And when they intersect, we're going to be finding the point of intersection, x and y. The second thing that could happen is that the lines could be parallel. And if they're parallel, how many points will they have in common? No points in common. They don't intersect. The third thing that could happen would be what? They end up being the same line. And if they're the same line, how many points will they have in common? Infinitely many points or infinitely many solutions. So those are the three things that are going to happen when you graph two lines or when you solve any system of equations. One of those three things. Well, in this set of problems, we're going to have to adjust one or maybe even both of the equations so that elimination can take place. Let's look at number one here. Now, again, don't write this down yet. We're just going to see what happens here. If I were to add these two equations, and remember, when we're using elimination, we're always going to be adding the two equations together. Now, if you were to talk to another teacher, another tutor, another tutorial somewhere, you might be told differently. This is the way I'm going to do it in this section for this class. It may not be the only way, but I think it's going to be the best way, at least it was for me when I was learning this. All right, so let's go back to number one, and let's see what happens when we add these two equations together. I add my x columns, and I get 3x. I add the y's, I get 5y, and when I add the 5 and the 6, I get 11, and nothing got eliminated there, did it? So we just can't add two equations together. And if I were to go through and change the signs, in one row like we were doing in the last section, remember? We get x minus 2x is negative 1x, and 2 minus 3y is plus 1y, and 5 minus 6 is negative, and that can't, well, remember, we want to eliminate one of the variables, so what can we do? Well, let's look at these x's. I have a 2 here, a 2x, right? What would I need in front of this x in order to get those guys to cancel out? Well, if I had a negative 2, wouldn't this negative 2x here cancel out the 2x there? Well, then that's what we're going to do. We're going to put a negative 2 there. But in order to do that, we're going to multiply, in this case, the top row, but we're going to multiply a row so that one of the variables will cancel. Now, actually, I said if it was a 2, it doesn't want to be a 2. What do we need that to be in order for them to cancel? We need it to be a negative 2, right? So here's what I'm going to do. I'm going to take, and it's the entire row, I'm going to multiply it times negative 2, and I'm going to put it here. So what's negative 2 times x? I'll get negative 2x. And then I'm going to take negative 2 times 2y and get negative 4y. And then I'm going to take negative 2 times 5 and get negative 10. Remember, it's the entire row. And that is a perfectly legal move to do, is I'm multiplying everything in that row by negative 2. It's the same equation, it just looks a little bit different because I'm multiplying everything by negative 2. But it is actually the same equation. Now I'm adding these two equations together, and look what happens. The 2x and the negative 2x cancel out. I'm going to take 3y and add negative 4y, and I get negative 1y. I'm going to take 6 plus negative 10 and get negative 4. If negative y is equal to negative 4, dividing both sides by negative 1, I get y is equal to positive 4. Well, now I'm going to take that 4 and plug it in for any y, doesn't matter. Let's just take this equation, it doesn't matter. X plus 2 times 4 should be equal to 5. X plus 8 equals 5. Subtracting 8 from both sides, and you get negative 3. So our point of intersection is negative 3, positive 4. Look at number 2. If I'm going to add these two equations together so that I get one of the variables to cancel out, if this were a negative 2 instead of a negative 1, wouldn't that cancel that x out? So what do I need to multiply by in the bottom row? I don't want to multiply by negative 2. Do I need to change the sign? No, I don't. Don't change the sign so you don't multiply by a negative. But anyway, I'm going to take 2 times negative x and get negative 2x. 2 times 2y is plus 4y. And then 2 times 5 is 10. And it's this equation and this equation that I'm going to add together. So I'm going to go ahead and rewrite that top equation. I'm going to bring it down, and I'm going to put it here. I'm going to have 2x plus 3y is equal to 4. And now when I add those two equations together, look what happens with the x's. They're going to end up canceling out because I have a negative 2x and a positive 2x. I get 4y and 3y is 7y. I get 4 and 10 or 14. Y is equal to 2. So I'm going to take that 2 and put it into either one of the equations. I'm not going to deal with the negative here, so I'm going to put it into the top equation. So 2x plus 3 times 2 is equal to 4. 2x plus 6 is equal to 2. When you subtract 6 from both sides, 2x is equal to negative 4. X equals negative 2, so you get the point negative 2, 2. In number 3, I tell you what we're going to do. I'm just going to, again, if you were to run across another tutor, another teacher, another website where you're talking about elimination, they may teach you something differently. And that's okay. I am just going to teach you one method. Actually, there's an infinite number of ways to solve a system by elimination, but I am just going to show you one way so that we all do the same thing for now. Maybe we can expand on that a little bit later on and explore some other possibilities. But for right now, let's arrange everything so that we always eliminate the x's. Okay? So let's just make it a blank statement. Right now, here and now, we're always going to be canceling those guys out right there. So if that's going to be the case, what coefficient do I need in front of the x? Well, if this one's a positive 3, I need a negative 3 here. So I'm going to multiply the bottom row by, that's right, negative 3. And it's, again, everything. So negative 3 times x is negative 3x. Negative 3 times 2y is negative 6y. And negative 3 times 3 is negative 9. I'm going to bring the top equation and bring it down here. Positive 3x minus y equals 2. And now I'm going to add those two equations together. Look what happens. The x's are going to cancel out, and that's what I want. We're always going to cancel out the x's. Now, negative 6y plus negative 1y is negative 7y is equal to negative 9 plus 2 is negative 7y equals 1. So let's put that into the top equation. Doesn't matter. I don't care. It makes absolutely no difference. We'll always come up with the same point here. So 3x minus y is equal to 2. I'm going to put the 1 in for the y, so I have 3x minus 1 is equal to 2. Adding 1 to both sides, 3x is equal to 3. X equals 1. So we have the point 1, 1 as our answer. Look at number 4. Let's go back up here to the top and let's review something. Sometimes we have to adjust one or maybe even both. So this is one of those cases where I'm going to have to change both equations because I have to get these coefficients to be opposites of each other. Does that make sense? I need one to be a positive and one to be a negative. Now, here's the easiest way to do that. I'm going to take the top row and multiply it by this number right here, because that'll give me what? 6. So I'm going to take the top row and multiply it by the bottom leading coefficient. So we'll talk about that later. Just suffice it to say that right now I'm going to take the top row and multiply it by 2. And what would I need to multiply the bottom row in order to cancel out the x's? Well, if I multiply it by 3, I'll get 6. So I'm going to have 2 times 3 is 6, and then 3 times 2 is 6. But I don't want both of them to be 6's. I want one of them to be a negative. I'm going to take my bottom row and multiply it by negative 3 in order to get negative 6. Now, look what happens. Here, let's do this. So I'll show you the difference here, what's going to happen here. Let's do that in blue here. So I'm going to take the bottom row and multiply by negative 3. So in the green, here's what we have. I'm going to take 2 times 3x and get 6x. I'm going to take 2 times 5y and get 10y. And I'm going to take 2 times 11 and get 22. Then I'm going to take the bottom row and take negative 3 times 2x is negative 6x. And look at that. I now have my x's arranged so that they're going to cancel out. Let's go ahead and finish multiplying out. Negative 3 times 3y is negative 9y. And negative 3 times 7 is negative 21. And that's exactly what I'm looking for. I'm looking for those x's to cancel out. So when I add those two equations together, I'm going to get 10y plus negative 9y is 1y, or just simply y. You don't write 1y, you write y. 22 plus negative 21 is 1, so y equals 1. Let's put that 1 back again. Whatever. Let's do the second equation this time. Doesn't matter. 2x plus 3y is equal to 7. I'm going to put 1 in for y. So 2x plus 3 times 1 equals 7. I get 3 here. So I'm going to subtract 3 from both sides to get 2x is equal to 4, x equals 2, so I have the point 2, 1. Go ahead and pause the video. Do number 5 on your own and see what happens. And again, if you go back to what we were talking about earlier, and that is always arrange it so that the x's cancel. Is that the only way? No, it's not, but that's the way I'm going to show you right now, and it's the way that works for me. And if we get to the point later on where we can expand on that, or if you see something different, by all means go for it. If somebody else shows you a different method and you understand that way perfectly fine, go for it. I don't care. It doesn't matter. But I need these two coefficients for right now to be opposites of each other. So I'm going to be taking the top row and we're going to multiply by what? 3. And I'm going to be taking the bottom row and multiplying by what? Well, in this case, negative 4, because 3 times 4 is 12, and negative 4 times 3 is negative 12, and that's what I'm going to need in order to cancel out those x's. So let's clean this up a little bit. So I'm going to take the top row and multiply by 3, and let's put that here. So 3 times 4x is 12x, 3 times 3y is 9y, and 3 times 8, don't forget to multiply this 3 times the 8. A lot of kids will forget about that. So always make sure you multiply all numbers. And then we're going to multiply the bottom row by this number, but we're going to make it negative. So I'm going to have negative 4 times 3x is negative 12x. Negative 4 times negative 5y is positive 20y. And negative 4 times negative 3, you have your calculator handy? 92. And look what happens. These are the two equations that we're now going to be adding together. And look at the x's. They're going to cancel out. And I'm going to have 9y plus 20y is 29y is equal to, right, 24 and 92 are 116. And when you divide both sides by 29, don't worry about it. It'll come out nice and evenly. Y equals what? 116 divided by 29 is 4. Again, so I don't have to worry about the minus sign and the negatives. Let's plug the 4 back into the top equation. I'm going to have 4x plus, now 3 times 4 is 12 is equal to 8. Subtracting 12 from both sides, I get negative 4x equals negative 1. So negative 1, 4. Go ahead and do number 6 and see what you come up with. So I came up with negative 5, negative 6, because in order to cancel out the x's, I only multiplied the top by 5 and the bottom by 2. Did you need to change the sign here? No. See, you already have one positive and one negative. So here's a little tidbit that'll help you out. If you don't need to change the signs, then don't change the signs. In other words, you don't need to multiply by a negative. You only want to multiply by a negative if you need to change a sign. We already have one positive, one negative here, so we don't need to change the sign, so you don't multiply by the negative. And you get, again, negative 5, negative 6. All right, now, do you remember what the steps are in solving story problems? A is to do what? Define two variables. What does that mean? It means pick two variables and tell me what they stand for. Then you're going to write two equations. How are you going to do that? Well, each sentence, remember this? Each sentence will what? Each sentence will give you an equation. Where do you find the equal sign? Right, the verb. Always be looking for the verb if you can. Then you're going to solve that system. We're either going to graph it, probably not. We don't have graph paper here. So you're either going to be using substitution or elimination. Since we're using elimination in this section, we'll probably be using elimination to solve these problems. And then always go back and make sure you answer the question. Okay, the sum of two numbers is 1. 8 times the first number decreased by 5 times the second is negative 13. Oh my God. Find those two numbers. All right, well, let's see now. Let's pick two variables, x and y. So let x equal, what does it stand for? Well, let's try the first number. This will change as the story problems change, but all we know is that we have one number and another number. We're going to let y equal the other number. Okay? Now, the sum of the two numbers is 1. There's a sentence that's going to turn out to be an equation. Where's the equal sign? Is. So something is 1. Well, what's equal to 1? Well, the sum of the two numbers. What are my two numbers? X and Y. So x plus y is equal to 1. Now, the other equation comes from the other sentence. 8 times the first number increased by 5 times the second is negative 13. Where's the equal sign? Is. So something's going to be negative 13. Well, it's not just like we were doing before. It's not just going to be x minus y. We have to take the story problem and actually translate it from the English into math stuff. Well, what's the math stuff? Well, what's the math stuff for the first number? What are we calling it? X. Well, then what would be the math stuff for 8 times the first number? Well, it'd be 8 times x. So put 8x. Then it says increased by. What's math stuff for increased by? Well, that'd be a plus sign. And then 5 times the second number. Well, what's the math stuff for the second number? Well, we're calling it y. What would 5 times that be? Plus 5y. So here we have x plus y is equal to 1, and 8x plus 5y is equal to negative 13. And guess what? You know how to solve this using elimination. By doing what? Well, we're going to cancel out the x's. Always cancel out the x's. Just makes life easier for right now. What do we need to do to the top row? What do we need the coefficient of x to be? How about negative 8 to cancel out the positive 8? So we're going to multiply the entire top row by negative 8. We'll keep the bottom row the way it is. And when we add the two equations together, we get the x's to cancel out. We get negative 8y plus 5y is negative 3y is equal to negative 8 minus 13 is what? Negative 21. Y equals 7. Are we done? No, we have to find out what x is because it says to do what? Find the two numbers. So x plus 7 is equal to 1. Subtracting 7 from both sides, you get negative 6. So our two numbers are negative 6 and positive 7. In number 2, there are two numbers again. 2 times the first number increased by 3 times the second is 4. 3 times the first increased by 4 times the second is 7. Find the two numbers. Go ahead and pause the video. See if you can come up with the answer on your own. Well, I came up with 5 and negative 2 for my two numbers because 2x plus 3y is equal to 4, 3x plus 4y is equal to 7. Multiply the top row by 3, the bottom row by negative 2, and you are on your way. Number 3, Jeremiah was shooting baskets in the gym. He shot both 2-point shots and 3-point shots. And if you're a basketball fan at all, you know what I'm talking about here. But he made a total of 48 baskets, and he made 113 points. That's what it's saying there. How many of each type of shot did he make? Well, what are the type of shots? Well, there are 2-point shots, and there are 3-point shots, right? So we need to take two variables and define those two things. So let x equal the number of 2-pointers, and let y be the number of 3-pointers. Doesn't that make sense? Because he's going to be making some 2-point shots, and he's going to be making some 3-point shots. Now, how many? Now, before let me clarify some things here. Before I would say take each sentence and write an equation. In this case, we're going to take each fact and write an equation. What's one fact? Well, one fact is that he made a total of 48 baskets. Now, he made a bunch of two-pointers and he made a bunch of three-pointers. So the number of two-pointers is X and the number of three-pointers is Y. And altogether, he made 48 of those. So X plus Y is equal to 48. Now, he scored 113 points. So wouldn't we take 2 times the number of two-pointers? We'd take 2 times those number of baskets plus 3 times the three-point shots, and altogether he made 113 points. So this is the number of baskets that he made, and this equation shows the number of points he scored. And to solve this system, we would multiply the top row by, that's right, -2. So we get -2x minus 2y is equal to negative 96. 3y minus 2y is y. 113 minus 96 is 17. So he made 17 three-pointers. So how many two-pointers did he make? Well, let's put the y back into the equation, the first equation. We have x plus y is equal to 48. X plus 17 is equal to 48. X is equal to 31. So he made 31 two-point baskets and 17 three-point baskets. Let's see how you do on the assignment. We'll talk about this more if you need to. Have a good day.